So we have a theory here, even though the previous person turned the TV off. We think that the problem with the flickering was actually a port on my laptop. So I have this plugged into a different port. The last experiment we did, this worked for a 4-hour class, so we'll see. Cue the flickering. His head flickers right now. So we'll see if that fixes it. I don't think it's a bad port. I think I am pretty rugged with this laptop and it's been around the block a couple of times, so I think just one of the ports is a little loose. So maybe that's just should be my charging port and everything else is reserved for everything. Okay, so this is not us. Oh, actually, I think I need to operate off of, yeah. There was an issue with iCloud last time. Just going to do something here real quick. Here, I'm just going to go from our slide with our languages down. Oh, no, it's updated now. Yeah, there was an issue with iCloud during class last time where any saves I did they were not actually saving to the cloud, but now they're up there. So I ended up saving the thing as a copy just in case we didn't lose anything. Okay, so at the end of class last time, I introduced, this kind of goes back to this idea of how do human beings solve problems. We remember stuff, we ask questions, repetition. 100% of programming languages give us facilities for those 3 things. So I showed you how to do those 3 things in Python. All right, so this is me defining some variables. I have a variable name, I put in there a value. I have a variable name, I put in there a value. Name value pairs. This is my ability to remember something. I remembered it right here. And then I proved that I still remembered it right here when I printed it. Make sense? Okay, that's the use of variables. That's variables in Python. Similarly, I'm going to come back to this here in a second. Conditionals, being able to ask questions. Okay? This allows me to ask a question, an if statement. So I'm asking if my variable called age, which is set to 41, if that's greater than or equal to 21. Okay, now we've seen these kind of mathematical comparisons before, right? At math class, you've had less than, greater than or equal to, those things. Okay, so those are familiar to us. I'm going to show you a couple of new ones that are, let's call them programming specific. So that gives us the ability to say ands and ors, as well as something called an exclusive OR, but don't worry about those right now. We're going to be dealing with math for a while. All right, so in any case, this is nothing new for us. We're asking a question if the current value of age is at least 21, is what that says. If it's greater than or equal to 21, then we're going to do all the stuff in here. Now, I can have a whole bunch of lines of code under here if I want. What's important, and this is a Python thing, I mentioned the last slide here, Python truth. Python's extremely picky about indentation. And that's actually why Python is such a good first language. It forces you to write structured code. All right, so when you look at this if statement, everything that is indented underneath that if statement belongs to that if statement. Okay? As opposed to something like this, where technically this guy looks like it's underneath his if statement, but this line will happen regardless. Actually, this breaks the else here, but just roll with me here. This line will happen 100% of the time, regardless of whether this is true or not. Because this line, because it's not indented under the if, is not part of this question. It's like a separate section of logic. Okay? So if I want code to conditionally get executed. I want these 4 lines in this case to only occur if this Boolean expression is true. All right, that's what I'm saying there. We have this optional case for if statements. We can optionally have an else. I put it in here, but we don't have to have that. Okay, I can take that guy out, and now only if I'm greater than or equal to 21 will it say this. Otherwise, it's just not going to say anything. There won't be an alternative answer. Okay, so this code conditionally executes. When you have an else in there, you're guaranteed that one of these 2 things will occur. If this is true, everything underneath that if statement will occur. Otherwise, everything underneath the else will occur. Make sense? If I take this else out of here, and I do that, what should the output be based on what we've been talking about the last few minutes? When will this print out? Always. Always, 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 that line will print out. Because it has nothing to do with this if statement. Because it's not indented underneath it. All right, so whether this is true or not, this line will print. All right? In this particular case, age is currently equal to 41. So is 41 greater than or equal to 21? Yes, it is. So it'll print out an enthusiastic let's hit the bar 4 times. And then it'll also print out this. If I change this 41 to just 4, enthusiastic toddler. They have a really convincing fake ID. All right, so if I change the age to 4, we come here. This variable name will resolve to its value. So age becomes the value contained in age, which is 4. Is 4 greater than or equal to 21? It's not. So since this guy boils down to false, none of these things will print. Make sense? But this line still will print because it has nothing to do with this if statement because of the indentation. Make sense? If I was using a different programming language like Java, for example, if I want to just show you the equivalent of this in Java, so I would say something like if age is greater than or equal to 21, I could say, actually, let me just do this for simplicity's sake. This is the Java equivalent of this code up here. But now what Java will let you do is this code still works identically if I write it like this. Because Java does not rely on indentation, it relies on something called a block structure, which is this opening curly brace, closing curly brace. Anything that's inside of those guys belongs to this if statement. Doesn't matter if you've indented it or not. In fact, Java really doesn't care if you just put all these guys on one line. In fact, Java's cool with that. Not very easy to read for a human being. You got to scroll all the way over here, but Java's fine with it. Not a big issue. I'm actually missing some semicolons in here between these lines. This should have semicolons. That's how Java tells the difference between the lines. Okay, but you see in a language like Java, C#'s the same way, C++ is the same way. While I can tell you as a teacher that you should indent your code and that makes your code look easier to read and all that stuff, it's very common for a beginning programmer to just slap code all over the place. Python forces you to indent it. Go ahead.
I was going to ask
always indent, regardless of what language you're working with. Is this easier, or what I have written right here, even though I'm telling you it will work, is that easier to understand or harder to understand than this? Okay. This is substantially easier to read than it was a second ago, right? Okay. Even though Java doesn't care. Make sense? So, as a human being, when you write Java code, you're going to indent it just like we are forced to indent it in Python. So that's why Python's a good first language, because it forces you to get used to that indentation procedure. I can't emphasize enough how important indentation is, because especially as a beginning programmer, when you go to start debugging your program, because I promise you, you're going to have errors. Okay, you're going to type in code. I think I mentioned this last time too, and I'll mention it over and over and over again. You're going to type in stuff. You're going to say, I wrote exactly what you wrote, and I got 4 million errors. Okay, and then you're going to have to go and figure out how to debug it and things like that. Well, it's going to be a lot harder to debug code that's just all over the place. Okay, Python doesn't even let you start with that. Java, you could just write crappily formatted code, no problem, and Java's cool with it, but you won't be able to read it. So now your bugs will be that much harder to fix. Python at least forces you into a structure, but you do need to be careful that you understand that these lines being indented underneath this if statement means they belong to that if statement. If you wanted this last line here to actually always execute and not belong to that if statement, you would then have to know, I need to have that guy not indented under the if statement, so now he happens all the time. That makes sense? Indentation is key in Python. Python does not care how much you indent as long as you're consistent. So if you want to always indent by like 2 spaces or something like that, you can do that, but you'll find like an atom, it indents for you, and it's like a tab. All right, so the important thing is that it is indented. Most of the time you're going to be using a text editor that makes your life easier. But if your code looks sloppy, that's probably what the first thing you need to start fixing before you start debugging whatever the error is. Okay? Another word of advice that isn't going to make tons of sense yet, but I'll say it now since it's on the top of my head. When you get an error, read what the error says. So often what happens is programmers, you're working on stuff, you see an error, and you're just like, oh, something's wrong. You jump back into the code and just start changing stuff. Okay, and then what ends up happening is after you've been working on your homework for 4 or 5 hours, you've tried every single permutation of those 4 lines of code, and it just starts working, and you have no idea why it works. That's the last thing I tried. It just works now. Read the error so that whenever you make a change to the code, you're making that change for a reason. It might not be the right reason, but it's still a reason, because you're going to learn far more from the things that don't work than the things that do work. Okay, we learn more from our mistakes than we do from our successes, right? So eventually you'll run out of problems with simple programs. Like, I've already made all those errors. I can't screw up that way again unless it was a typo, something like that. Okay, so questions about this indentation stuff? I'll take this Java code out of here, but this actually kind of proves the point. I said the language doesn't really matter. This is a loosely typed, interpreted programming language. This is a strongly typed, compiled programming language. They look pretty similar to each other. Okay? Here, I'll give you a right there, 1968 C. Believe me now that all these languages came from C? Yeah. They all look pretty much the same. Every now and then you'll bump into a language that's a little weird. I mentioned Objective-C is kind of a weird language, but actually the Objective-C version of this would look pretty similar as well. The difference in Objective-C would be, I'll just roughly write it here. I'll just roll with it. Pretty much looks similar, except we got this weird square bracket syntax thing going on here. Objective-C uses this concept called message passing. After you get past the little strangeness in the syntax, it's all the same. Okay? So we all believe that all these languages came from C, and once we know how to program as a skill set, we can take that to any other programming language as long as we ask ourselves, how do I remember things? How do I ask questions? How do I do repetition? I can already solve a whole bunch of problems in that language. Yep, 100% truth. Okay, but we're dealing with Python here, and Python is very picky about indentation, and all these other languages, you should be picky about indentation. Okay, it's not going to force you to do it. All right, so then down here we have loops. So this guy down is, we have a for loop and we have a while loop here. So for loops are typically for counting type problems. So let's add a couple of things in here. So let's just say variables. Syntax for this is var name equals value. So for example, name is equal to Mike. Okay, and you could put all sorts of spaces in here if you want. Python doesn't care. Okay, but typically you would just format it so it doesn't look weird. So maybe you have one space on either side of the equal sign. That looks clean enough. If you want to have 0 spaces, you can. All right, so age is equal to 16, stuff like that. So it's the name of the variable equals the value that that variable holds. All right. Now variables can change. Their values can change. They are variable. So I can later on say name is equal to Luke, for example. I think I showed you last time. You could also technically say name is equal to 12. And Python would be cool with that, but now this is a little misleading. You're putting your shoes in the container marked for taxes, and while that technically is okay, and if you come back within the next week, you might remember that, but if you look back under the bed in 7 years, you might, and you're looking for those shoes. Honestly, we all collect a lot of shoes. I saw some stat the other day that like the average female has something 20-some pairs of shoes and the average male has like 11. I mean, like we all have tons and tons of shoes. So at some point you'll just get desperate. Like you've been so lazy about buying shoes that you'll just rip through your current pair of shoes. Like, okay, I need to find that. I need something on my foot, right? And you'll go under the bed and you'll never find that shoe because it's in the opaque container labeled as taxes. Okay, this is a real life example, people. This happened. All right, makes sense? Probably name your variables something reasonable that tells you something about what is inside of that variable. We would be very surprised to find the number 12 inside of a variable called name, even though Python is cool with it. All right, but it would be much less surprising to find things like Mike or Luke inside of a variable named name. All right, variables don't have to make any sense. We could just say I just banged on the keyboard. Okay, as long as there's no spaces in there and it didn't start with a number, Python's cool with it. Okay, so variables have to start with a character. They can contain numbers that just can't start with a number, and no spaces in variables. Python will be happy to scream at you if you've used a variable name that isn't allowed. You also can't name variable names reserved words. So for instance, I can't say lowercase 4 is equal to 12. The word FOR, because that's reserved for loops. Shows up in pink in here inside of our inside of Atom. Most text editors will color code it in some way to let you know this is a reserved word, a special thing. You can't reuse those for your own variables. Those are reserved for the language. Make sense? Pretty much common sense. All right, and again, Python will be happy to scream at you. It will say something along the lines of, for cannot be a variable. It's a reserved word in the language, yada, yada, yada. It'll probably say that in a much weirder way. So a skill you will need to to learn as a programmer is how to read error messages. Because a lot of times it's like, the proverbial reads like stereo instructions, something like that. They're usually actually pretty accurate. You just have to kind of learn the weird way they present things. All right, so questions about syntax for variables? So 100% of the time when you use variables in Python, this is the syntax. All right, next, conditionals. Syntax is if Boolean expression followed by a colon. I'm going to go ahead and just use this guy for indentation here. You don't put the bullets. All right, so I'll just say logic, logic, dot, 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 logic, whatever logic you want to have inside the if statement, but indented under the if statement. Okay? Optionally, you can have an else with logic indented underneath it. All right, but this line here is optional. You can have an if without an else, but you can't have an else without an if. All right, questions about conditionals? Go ahead. Absolutely. Yep. Good. Really good question. So what he's asking is this. I can say something like, let's start age off at 18, like that. So we'll say if age is greater than or equal to 18, teaching all sorts of bad habits. You can buy cigarettes at 18, right? Okay. Get some smokes. Don't do that. Bad habit. But then you can also say if age is greater than or equal to 21, hit the bar, something like that. So if our age is greater than or equal to 18, this will print. And then we'll ask another question inside of there. Notice it's indented. So this if belongs to this if. So we're asking another question. So if this guy is true, things that are indented under there will happen. Yep, so you can have things, these are called nested if statements, or you can also do it with loops, nested loops. All right, make sense? Okay, so that's conditional. So really when I say logic here, logic is any of these things. Variables, conditionals, loops. All right, any of the things that you can write code for equals logic. All right, so that's conditionals. Loops, okay, we have several different loops in Python, so I just showed you two so far. So we have a for loop. Actually, in most languages, this would be called a. Actually, no, this is just a normal for loop in most languages. So a for loop is the word for followed by a var name in range of values, colon, logic. Okay, so what actually is happening in here is, if you see our code out in here, I have this function I'm using called range. This is going to give me values between 1 and 11. And what it's actually providing me is something that looks like this. So that range function generates a list containing 1 through 10. So then what it's doing is it's saying, for I in this collection, this list, print out I. First time through, I will be 1, then 2, then 3, then 4, so on and so forth. Okay? We're going to talk about some of the inner workings here. So for right now, I want you to view some of these things from the perspective of, like, you ran to Home Depot, you bought this for loop thing, and it has this weird black box on it that you know there's some smart stuff inside of it, but you haven't cracked it open yet. So you just happen to know that this will take us on a voyage between 1 and 10. That's what that guy does. You don't necessarily have to know how it works yet. Go ahead.
I'm just curious on why 1 is included, but 11 isn't.
Just the way the syntax works. It's just not inclusive.
Okay.
Yeah. Yeah, it's just the range function takes 2 parameters. The first one is inclusive. The second one is exclusive. Just how that function was written. And it kind of goes back to, that's what the thing from Home Depot, that's how it worked, right? Tape measure started at 4. That's why it was on sale. Started at inch 4, so you missed 1, 2, and 3. You never gotten one of those for sale tape measures? It's like clearance, 99 cents. You know, somebody hit it with a bandsaw or something like that. It's like missing the end of the tape measure. Dirt cheap tape measure. If you're only measuring like things for like wall studs and picture frames and stuff like that, you don't need 1, 2, and 3. You just extrapolate from 4, 5, and 6. Problem solving. Okay, of course I've never cut the end off of a tape measure before. It's so easy to do. It's a little scary though. I've cut multiple tape measures off in a table saw, which is kind of scary because then you wonder, why haven't I cut fingers off in a table saw? Which is why I no longer own a table saw. Okay, so this makes sense what this guy does. This is a little Home Depot thing, and this guy just happens to take I on a voyage between 1 and 10. That's what that tool does for us right now. Cool? All right, we don't need to know any more about it than that, because, I mean, what we're going to be doing here over the next many weeks, well, really several years, is we are solving problems. We are telling our computer what to do in terms of the tools that we have in our toolbox. And we're going to continue to collect things from the Home Depot for programmers, something like that. Okay, so right now we have variables, we have if statements, and we have a for loop that goes through some numbers. We got that. That's our guy. Okay, so we're pretty limited on what we can do with that, but we can do some stuff with that. Okay, now this other guy down here, this while loop, and let me introduce something here real quick. This really goes before even if statements, because if statements and loops both use these. We have this thing called a Boolean expression. Okay, and if you looked at conditions here, I mentioned Boolean expression here in our syntax for conditions. I thought I did. I introduced this last time. So it's true or false. It's any expression that boils down to a single value of true or false. So like when I say age greater than or equal to 21, my variable age will boil down to the value that lives in it, so like the number 17. And then I'm asking a question, 17 greater than or equal to 21. That boils down to a single value of true or false. In that case, 17 greater than or equal to 21 will be false. 17 is not greater than or equal to 21. If age was instead 41, is 41 greater than or equal to 21? Yes, it would boil down to true. So Boolean expressions are any expression that boils down to a single value of true or false. Make sense? And again, we are going to learn more and more complex ways of writing Boolean expressions. So maybe the word of warning I'll just give you out loud right now is when you see an expression and you're trying to determine if that guy is a Boolean expression, don't judge a book by its cover. Sometimes you will have something that looks really, really, really complex, or at a glance it looks like it's something else. But once you walk through it and you resolve all the little pieces of it, you realize it actually is a single value of true or false. Okay? So, and I'll point that out when we see some examples of that, but one of the things we have to do as a programmer is we have to slow our minds down and really ask ourselves what is happening. So if I go back up here to variables, I'm just going to add a line after this. Call this guy variable resolution. So we use variables as placeholders in our code so that the actual value that lives within a variable is usable at runtime. All right, so we've seen some examples of that. We want to ask a question about the person's age. If age is greater than or equal to 21, we're going to do something. Age could change before we get to that line of code. So we've used that variable name age as a placeholder. When we look at the code here, I've said whatever age happens to be equal to when I get to this line of code. That's what I'm asking this question about. Make sense? So when our code actually runs, so at runtime, variables will resolve to the value they contain. So we call that variable resolution. It happens automatically, but it's a really, really, really important concept because it's kind of our first little step as beginning programmers into slowing our mind down and saying, what is the current value of age? Before I finish asking the question of whether or not it's greater than or equal to 18. We have to first resolve that. The computer's going to do it super, super, super fast, but if we're following the logic of our code, when we hit this guy, we know he's a variable. Why? Well, first of all, he's not in pink, so he's not a reserved word, and it's also something we defined up here, so it should seem familiar to us. But this dude's a variable, and in order to fulfill our logic here, we need to say, what does this variable actually equal? What value is it remembering for us? Make sense? That's the purpose of variables, to remember stuff for us. How do human beings solve problems? Memory, asking questions, repetition. Okay, so we would look at this and we'd say, what is the current value of age when we get to line 11? In our case here, age is 18 here. It doesn't change at all in here. So when we get to this line right here, it's still equal to 18. So it resolves to 18. Make sense? Okay. So when I say variable resolution, that's what I'm talking about. Okay. So we already hit Boolean expressions in there. So conditionals require Boolean expressions. For loops, there are versions of for loops that do require Boolean expressions, but the one we bought from Home Depot right now just counts between some numbers. Okay? But I'm going to show you a second kind of loop called the while loop. So this guy is while Boolean expression colon logic, dot, 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 logic, whatever you want to put in there, indented underneath it. Okay? As long as this Boolean expression boils down to true, we keep doing this logic. In a conditional, as long as this Boolean expression is true, we do this logic once. Okay? If statements allow us to ask a single question and respond to it one time. Loops allow us to ask a question, respond to it, ask the question again, respond to it again for as long as the answer continues to come back as true. So loops let us do repetition. If statements let us do asking questions. Make sense? So we're kind of connecting some dots here. All right. And as human beings, we've already covered that we're great problem solvers, right? We spend every single day of our lives solving different problems. You know, you go to the cafeteria, they give you some kind of, you know, you get whatever you're going to get up there, and you come back and you got some various pieces of silverware next to you. When do you choose a fork versus a spoon? Do you even think about that, or you just pick up the right tool for what you got in front of you? Or if they're out of spoons, you just kind of make it work with a fork. Have you ever tried eating the soup with a fork? The cream soups work, but as human beings, we adapt, right? Sometimes they're out of spoons. You either don't eat the soup or you eat it with whatever you got in front of you. You make a little spoon with your... See, when I went to India last October, they were really impressed by me because a bunch of my Indian grad students, they taught me how to eat like an Indian. Okay, and they eat with their hands. And at first you're like, okay, well that's weird, not civilized, whatever. Well, a lot of the foods they eat really rely on you being able to like mix stuff together. It's very important. Well, plus they have like this rice dish called biryani that is all sorts of different flavors and spices and stuff put in there, but it also has this meat, but the meat is still on the bone. So you have a bowl of rice with hidden chunks of bone inside of it. Okay, where if you're eating that with the, you know, you're just shoveling it in with our utensils, it's going to be a rough go of things. Okay? But when you're eating with your hands, you can pull the meat off the bone really easily with your hands. You get everything, all the flavors mixed together, and then you push it into your mouth. Okay, so you make a little. It's actually really efficient. You know, when I first started, when I first met them, and they were doing that, I'm like, you guys like Neanderthals. It's like one step above the zoo. Okay, but then they teach you how to do it, and it's good. I had people come up taking pictures with me at restaurants over there because I was this, you know, giant American. They really follow wrestling over there. It's like WWE wrestling, and there's this wrestler called Big Show that apparently I look something like. I'm about the same weight as him, but he's about 4 or 5 inches taller than me. But to a person in India, I'm a giant American. Okay, so they thought I was Big Show. So they're taking pictures of me. We went to a church over there. They're taking pictures of the kids coming up to me like during the service, taking selfies.
That's awesome.
Okay, yeah, and I embraced it because it's just fun, right? Of course, I'm Big Show. I had to go look up and find out what his signature death move is, because all the wrestlers they give the signal, right? Yeah. I remember when I was a kid, one of the famous wrestlers was Jake the Snake Roberts with the patented DDT. And he'd always let you know when it was coming, right? The other guy in front of him was hurt, and then he'd just give the little signal. DDT's on its way. Oh, my brother and I bought that for years. Actually, I still buy it. That'll be on the midterm, by the way, everything we just talked about. What was Jake the Snake Roberts' signature death move?
Really?
Then afterwards, he'd go and get his Burmese python and throw it on his victim. Yeah, he kept a snake in a bag ringside.
What?
Oh, yeah, George the Animal Steel, he'd go and eat the turnbuckles.
I mean, this is the same organization that the Undertaker is a concept so old that literally.
Yeah, but Undertaker's a lot newer.
Yeah, but that's my point.
Yeah, I'm back. Hulk Hogan, Andre the Giant, Junkyard Dog. The Russian tag team, the Bolsheviks. And then you also had a WWF cartoon back then.
What?
Oh, yeah. You had the good guys versus the bad guys. Like Hulk Hogan was the leader of the good guys, and Andre the Giant was Rowdy Piper was the leader of the bad guys. All on the quiz, people. I should give you a joke quiz one of these days where I just hand out like, okay, what?
WWE quiz.
All right.
They'll be graded. Stars on it.
The more you know. All right, so while loops, we have a Boolean expression that we test, and then as long as that Boolean expression is true, we continue to go through the logic. But we do this multiple times potentially. Okay? Now I'm going to throw something out here. We're going to call this pre-check loops. Okay, so while loops are an example of a pre-check loop. A pre-check loop means we ask the Boolean, well, we test the Boolean expression. Or we can think of it like we ask the question. We test the Boolean expression before we execute the body of the loop the first time. Okay? So we test the Boolean expression before we execute the body of the loop the first time. So that means that pre-check loops execute the body 0 or more times. There is no guarantee. If I look at my code back here, there's no guarantee that this while loop will ever actually run. So for right now, I say while age is greater than or equal to 0, I print out age, and then I subtract 1 from age. But let's say that I started age off at -18. Is -18 greater than or equal to 0? No, it's false the very first time. So we fall past this and continue our program right here, which we run out of code now and we're done. Make some sense? Okay, so now we've been introduced to our new tools from Home Depot. We know how to remember some things. And when we remember things, we probably want to give them variable names that are meaningful based on what they're holding. We know how to ask questions, and we know how to write some loops. So what we want to do for homework is, I'll give you kind of a starting point here real quick. I have a number of pennies, and we'll put this in some, so let's say 1,013. We have 1,013 pennies. Okay, so what we want to do is we want to print out the best way of giving change where our highest amount is $1 bills. So you're going to give as many $1 bills, followed by as many quarters, followed by as many dimes, followed by as many nickels, followed by pennies. So you'll print out the change is this many dollars, this many quarters, this many dimes, this many nickels, this many pennies. Make sense? So you'll have to whittle this number down in order to accomplish it. All right, I'm going to show you 2 things that you're going to need for this real quick. One of them, I'll just do, so I'm going to say number of dollars is going to be equal to number of pennies. Do 2 divide signs like that. Divided by 100. That'll get you number of dollars, right? Then we're going to update number of pennies to be equal to number of pennies mod 100. This gives me the remainder of long division. Okay, remember we talked about long division? Now I want to, yeah, this should be fine. All right, so this gets you started. So you'll want to do more variables for the other denominations and then print them all out in the end. Make sense? I'll give you this as a starting point in the assignment, but for Friday, set this variable to some number of pennies, then the rest of this should all work. If you go back and you change this to a different number of pennies and run your program again, it should give you a different result. Questions, comments, concerns, bribes?
That mod, is that a
Percent symbol.
percent?
Yep. I will double check that. I'm pretty positive it is the percent symbol in Python 3. It might be mod, like that. I think Python 2.7 is mod. Python 3 is percent symbol. I'll confirm before I put the assignment up. Okay? Most of our newer languages use percent symbol, so I'm guessing it's percent symbol. All right, I'll see everybody on Friday.